heavy object is released from rest in position 1 above a spring, it falls in contact with spring in position 2. Spring achieves maximum compression in position 3.
Negative or 0.
From in the intervals. What do they mean? So it falls, it hits the spring, and then compresses it that much. And then, where? Oh, change in, okay, change in kinetic energy. Change in gravitational energy. Okay.
So 1 to 2, be 0.
For which one?
For 1 to 2, so from 1 to 2.
Right, but for kinetic energy.
Oh.
So this is kinetic energy, this is gravitational potential energy, and this is spring potential energy.
Okay. For kinetic, 0.
Well, what's happening, it hits here and it falls. Right before it hits the spring, does it have kinetic energy? I guess, let's look at it this way. So what kind of energy does it have before it falls?
Gravitational energy.
Okay. And then right here, what kind of energy does it have?
Gravity.
So it still has that. Actually, let's label them this way so it's easier. So up here you've got UG, you still got UG, but what else is happening now?
Yeah, the spring holding it up.
Well, it's right before it hits the spring,
Oh.
but it would drop and it would speed up until it hit the spring, right? So this would actually still have kinetic energy right there. And then it hits the spring, and what does the spring do?
It crunches up. Good, it's compressed.
Right. So you'd get spring potential energy. At the bottom, it would stop, right? So it wouldn't have any more kinetic energy.
Right.
And if we put our datum for potential energy right there, then it doesn't have any gravitational potential energy either.
Okay.
So from here to here, did kinetic energy go up, down, or stay the same?
Down.
Well, we started with 0.
Oh, go up.
Yeah. So the thing about kinetic energy is that it doesn't matter what direction you're moving. It's always going to be positive. If you have any speed at all, it'll be positive.
Okay. Gravitational energy would be positive.
Well, you still have it here, but is it going to be higher or lower?
Lower.
Yeah. Because your height is lower. So that'll be negative.
And then
So this is right from where it's dropped to right before it hits the spring. Has the energy in the spring changed at all?
no.
This will be 0.
Okay, so 2 to 3.
So what happens to your kinetic energy?
Goes to 0.
Right. it had some kinetic energy at first, right? And then it compressed that spring and stopped.
Right.
So it went from positive to 0. So that would be a negative change.
Gravitational energy, that'd be negative.
Yeah. Because no matter what, it's still moving down. So it's still going to lose gravitational energy.
And the spring, that would be negative.
Well, you had none here. Now you have some.
Oh.
Compress the spring. So whether you compress the
Is
spring.
this talking about just like the energy? in the
Yeah, this
spring?
is the change in the energy.
Okay.
So this is saying that from here to here, our kinetic energy increased.
Right.
From here to here, gravitational potential energy decreased. From here to here, our spring energy stayed the same.
Okay.
So now from here to here, kinetic energy has gone down. Gravitational potential energy has gone down. But from here, as you stretch the spring, what happens to your spring energy?
It increases.
Right. So that would be positive.
Then 1 to 3, kinetic energy, it starts out positive, but once it hits 3, it decreases. So it's negative.
Well, it's talking about from this point to this point. So you're just skipping past this. Right?
Alright.
So you started out and it wasn't moving. And then when it hit the spring and stopped, it's no longer moving. So we're not worried about what happens in between, we're just worried about the total change.
Okay.
So it started out not moving at the top, and then at the bottom it wasn't moving again.
So 0.
Yeah. That's kind of a nice thing because, like, for example, this just happened the other day in dynamics, we're doing the same stuff. And we did a problem where, like, you know, something comes down a hill and there's a spring right here. And a lot of people were finding the gravitational potential energy here. They're finding the kinetic energy here, and then they're using that to solve for the spring energy. So they were doing 1 to 2, 2 to 3. But it turns out this energy is going to be the same as that energy, so you can skip right to the end. So you don't really care about the kinetic energy in the middle, as long as it goes away. Okay?
And the gravitational energy goes from, that'd be 0 as well.
Well, it started out pretty high and then it dropped,
And then,
so it'd be negative. It ends at 0, right?
so when it stops at 3, it stopped, right?
Right.
Does that mean it's 0 right there, or is it? Does that make sense?
For gravitational potential energy?
So, because like the spring is, like it can't be compressed anymore.
Right, so the thing with gravitational potential energy is it's just based on how high the object is. So like this object has more gravitational potential energy than this one. And then like, if you put another one down here.
Well, I guess gravity's always acting on it.
Right. And the thing about it is that you get to decide where you're gonna measure height from. Because gravity is just NGH. So you could say that you're gonna measure it from here, right? Then you would say that this point had no gravitational potential energy. But then this is a negative height. So this would have negative potential energy, gravitational potential energy. And this would be even more negative. But it would still show that this is the highest at 0. This is negative whatever. This is the lowest negative number. Or what makes more sense to us is to put call it the datum right here. So that way this height is the highest height, so it has the most potential energy. This one isn't quite as high, so it has less potential energy. Then this one has it's just a 0, right? So it wouldn't have any potential energy. So that's what we've done here. So we just draw our line for where we want to measure potential energy. We put it where we want, so it's convenient, so it'll disappear, right? Because that way we don't have to worry about, if we put it down here, we'd still have to worry about potential energy from this height. But either way, no matter where we put it, the height from here to here, versus from here to here, this height is much greater.
Gotcha.
So if you want to find out whether or not gravitational potential energy has gone down, you just look at how high it is compared to the next place. So this still goes down.
Negative.
Yep.
And the spring is positive.
Yep. So you kind of see like the pattern here, because energy is conserved.
Mm-hmm.
So in this case, your gravitational potential energy went down, and it turned into kinetic energy. So they just kind of switched. So one was here, the other one was here, and they just kind of like moved up like that. And then in this case, kinetic energy went down, gravitational potential energy went down, and your spring energy went up. So all of this that those two lost went here. Does that make sense?
Oh, okay, yeah.
So this went into that.
So there's always at least one positive and
Yeah.
positive
Yeah.
force or energy.
There'll always be one that's positive and there'll always be one that's negative. Unless nothing changed, right? Then it'd just all be zero. But they all have to be able to equal out. So they can't all be negative, right? Because that would just be without any kind of work done.
That wouldn't do anything.
Yeah, because they wouldn't be able to cancel out. But then like this one just went into that. Okay? But the main point here they're trying to get across is that whatever you do to change the length of the spring is going to increase potential energy.
Okay.
So if you take it from its original length and you compress it, it'll still launch a ball, right? If you take it from its original length and stretch it out, it'll launch it into itself, but it'll still move it. It's kind of like an airsoft gun or something. You know, when you pull the slide back, the spring is trying to pull it back forward, so you can feel it. It's hard to pull back, and then you let it go and it slides it back forward. And then when you pull the trigger, the spring unstretches again and it shoots the ball out.
Okay.
So the reason it's hard to pull back is because you're stretching one spring, and then it pushes it back into place. And then the one that was compressed is the one that's shooting the ball out. So either way, when you're stretching it or compressing it, you're still going to feel that energy.